Today our topic is percent composition by mass. Percent composition by mass. So there are two different ways that we can describe the composition of a compound. We can talk about what types of atoms are present and the ratio of those atoms one to another in a compound. And we can also describe that compound in terms of what percent of its total mass any particular element makes up of the whole. Okay, let me write that down. There are two ways. There are two ways to describe the composition of compounds. In terms of the numbers and types of atoms present Okay, what the heck do I mean by that? For instance, carbon dioxide. In one molecule of carbon dioxide, we can describe the composition of this thing by saying there is one carbon atom and how many oxygen atoms are there? 2. That's what the subscript tells me. And there are 2 oxygen atoms. Talk about the other way in just a second, but there is a point that I want to make here that's a really important point. And that is, if I have one molecule of carbon dioxide, in that one molecule of carbon dioxide, I have one carbon atom, so it says no subscript, and I have 2 oxygen atoms, so it says my subscript 2. Now, for whatever reason, we have a hard time blowing this up to a large number. Let's say, instead of having just one molecule of carbon dioxide, we have a mole of molecules of carbon dioxide. Okay, so I've got a mole of molecules. So, in that mole of carbon dioxide molecules, I will have 1 mole of carbon atoms and 2 moles of oxygen atoms. Okay, so this shows me not only my ratio of atoms to each other in the single molecule, but if I make it bigger and say, okay, I have a huger quantity of this, I have a mole of this, then it also describes how many moles of each element I have one to another if I have a mole of this stuff. Okay. All right, so that's one way we can describe the composition of a compound. How else can we describe how a compound is made up? We can also describe it or by the percentages by mass of its elements. Why do we want to describe it this way? Well, oftentimes, you guys, this is the data we can get from lab. And from that data, mass data, we can use the mass data to go back and figure out, and we'll do this tomorrow, well, the day after tomorrow, we can figure out using mass data what the chemical composition of the thing is. What are the ratios of atoms to one another in a compound? Okay, so today we're going to talk about how do we figure out percentage by mass of the components that make up a particular compound. So a question would look like this. Calculate percent composition by mass. Calculate percent composition by mass of hydrogen and phosphorus and oxygen in H3PO4. Okay, so we want to know total. What percent of this mass is coming from the hydrogen? What percent of the overall mass is coming from the phosphorus? And what percent by mass is coming from the oxygen? So that is the question that we are asking right now. Okay, so if we are trying to find a percent composition of each of these parts, what do you think we need to do first? We're finding percent of the parts to the whole. And so the first thing we have to do is calculate the molar mass of phosphoric acid just on its own, of the whole compound. So the first thing we need to do is find the molar mass of phosphoric acid. So you go for it right now. Pause me, and you find it. And what you should have found is that the molar mass of this compound is 97.99 grams per mole. So that is total molar mass of this compound. All right, so now what we have to do is we need to find the percent composition of each of its components. And so how do I do that? Well, let's first of all figure out the percent of hydrogen. How do we find any percent? Doesn't matter what topic we're talking about. It's the part divided by the whole times 100. So the whole is easy, 97.99. Right? The whole molar mass of this thing. Okay, we're looking for the part that is hydrogen. And so that is going to be, let's look at this compound. We've got 3 hydrogens, and they weigh in at 1.01 grams per mole. Okay, so of this whole, hydrogen makes up 3.09%. So 3.09% of the total mass of phosphoric acid is coming from the hydrogen. All right, what about the percent phosphorus? All right, we've got the whole, and it's 97.99. And let's see, what do we have here? We've got 1, and the molar mass of phosphorus is 30.97. Multiply that by 100, and we're going to end up having 31.61%. Okay, so that means that 31.61% of the mass of this compound is being contributed by the phosphorus. Okay, last but not least, it's the oxygen. Our whole is 97.99. And let's see, we've got 4 oxygens, each weighing in at 16.00. Okay, the part divided by the whole times 100, and we get 65.31%. Okay, somewhere I have made a rounding error because we've got 101% or 100.1%. Okay, sorry. All right, you guys, so here we go. These are the percent compositions by mass. So 3.09% of the mass is coming from hydrogen, 31.61% of the mass of phosphoric acid is coming from the phosphorus, and 65.31% of the mass is coming from the oxygen. Okay, so today it's very straightforward. Now, how we will normally see this kind of problem where we're dealing with percent composition by mass is going the opposite direction. And we'll learn how to do that tomorrow, and that is you're given percent composition by mass, and so then the question is, how do we work back from that to a formula?